Hello everyone, this is the first episode of my Arduino Basics series. Today I'm going to guide you through the Hello World project of the microcontroller world, which is making an LED blink. Let's get started. For this project we will need a breadboard, an Arduino, a 220 ohms resistor, an LED, two male-to-male jumper wires, and a USB cable. First, if we want to program our Arduino, we need to download the Arduino IDE from their website. The website is arduino.cc. Move to the software and click on the download tab and choose the right version for your operating system. I give you a link in the description below. After we finish the installation, let's take a look at the hardware. Let's start with the microcontroller. There are lots of types of Arduinos out there. I will show you 3 of them. First, here is the Nano. This one offers 32 kilobytes of flash memory and 22 input-output pins, or I/O pins for short. The Uno also has 32 kilobytes of flash memory and 20 I/O pins. The Mega has 256 kilobytes of flash memory and 70 I/O pins, so we can do quite big projects with this one. All of the mentioned boards have the same clock speed, 16 MHz. This determines how many instructions it can execute in a second. We will use the Uno for this series, so let's have a closer look. We can power and program the Uno through USB, and if the program is already uploaded, we can also power it through the jack. The Uno has 14 digital and 6 analog pins. These are the ones we can program to apply or read different voltages. Next, we have the LED, which stands for light emitting diode. Light emitting is clear, but what is a diode? A diode lets electric current flow through only one direction, so this means if we connect it incorrectly, it will block the current and our LED won't light up. If we try to connect the LED directly to 5 volts, we immediately burn it out because too much current will flow through it. So we want to limit the amount of current that passes through the LED. To achieve that, we need a resistor. But we have quite a lot in our arsenal. In order to choose the right one, we have to apply Ohm's law. The Arduino will supply 5 volts, and by looking at the datasheet of the LED, we can see that the continuous forward current is 20 mA. Rearranging Ohm's law, we got that the required resistor must be 250 ohms. Usually, we don't have the exact same resistor that we need from the equation, so we have to round up to the next biggest in our arsenal. But since our model of this circuit is not perfect, in fact pretty bad, we will be safe from anywhere from 150 to 250 ohms. I will use a 220 ohms resistor. The resistor also got 2 terminals, but unlike the LED, it does not matter which way we connect it to the circuit. Finally, we need a platform on which we connect all these components into a circuit. This platform will be a prototyping breadboard. The rails of the breadboard are connected like this. The blue lines mean connection, so if you put components in a rail with blue lines, they will be connected. And finally, we need 2 male-to-male jumper wires for connection. Let's connect the circuit. We can use any digital pin for this project to supply 5 volts, let's say pin 4. So we connect pin 4 with a jumper wire to the LED's positive terminal, which is the longer leg. Then connect the resistor to the negative terminal of the LED. Then the free terminal of the resistor to the ground of the Arduino with a jumper wire. Note that it does not matter if you place the resistor before the LED or after, the result will be the same. Finally, we need to connect the Arduino to the computer with the USB cable. Okay, now we are ready to write the code. When you open the Arduino IDE, you will see that some code is already there. It seems like there are 2 blocks, a void setup and a void loop. Everything you write in the void setup will be executed only once, and the void loop will run over and over again until you power off the Arduino. You can also see some other text in grey, they are called comments. These lines of code won't be executed because they have 2 slashes before them. This way the Arduino knows to skip these. Notice the brackets. The code we write must be within these brackets for the void setup and the void loop also. Okay, so we want our LED to turn on and off every second and keep doing that. To turn on the LED, we need to apply 5 volts to its positive terminal. We can do this by calling the digital override function. Notice how the function changes color when you type it correctly and not when we write, for example, with a lowercase w. The function takes inputs and produces outputs. In this case, it takes 2 inputs, namely which pin you want to apply and what voltage. So let's say we want to apply 5 volts, also called as high, to pin 4. Also, we need a semicolon at the end of every instruction we write. Okay, so now we want to wait 1 second. For this, we will use the delay function. This function takes 1 input, the amount of milliseconds you want your Arduino to wait, and the output is that it does nothing for that time. We type delay and 1000. Now we want our LED to turn off. For that, we will use the digital override function again, applying 0 volts, also called as low, to pin 4. Now we must wait 1 second in the off state. For that, we will use the delay function again with the same parameter. We are not done yet, unfortunately, because we did not tell the Arduino whether pin 4 will be an input or an output pin. We can do this by calling the pin mode function. It takes 2 inputs. The first asks which pin are we talking about, and the second asks if that pin will be an input or an output pin. So we write pin mode 4 and output. Now remember, the void setup runs once and the void loop runs as long as the Arduino is powered, so it makes sense to put this line in the void setup since we need to declare this only once. Now the code is ready to upload, but first we have to check if we are talking to the right device and on the right communication port. In order to do that, head to the Tools tab and then to the board. I use a Uno, so I check that, but if you use any other board, you need to check accordingly. Then to the Tools again, but now we need the Port tab. Here we usually need the Communication 3 port or higher. Now we can upload our code with the arrow icon. Finally, I will show you a more convenient approach to our code with the use of variables. We can store variables in the memory of our Arduino. They are essential and also makes our code more readable. For example, when we declared our pin 4, we just use the number 4. We can make a variable, let's say let pin, and make it equal 4. This way, whenever we use the word let pin, the Arduino will know we talk about the integer 4. Now, when we call the digital override function, it will be much more obvious that we want an LED to light up. Do the same with the another number we used for the delay functions. Let's name them on time and off time and make them equal 1000. Remember to give your variables descriptive names, so they will make your code more readable. There is one more thing we have to do: give these variables a type. They are integers, so we have to write int before their names. Now we can just type the names of these variables in the place of the previous numbers. Let's upload the modified code. Works just like the original. Let's try to change the value of the on time and off time and see how the blinking behavior changes. We have done quite a lot in this tutorial. Next time we will use a button, digital read and conditionals. If you got interested in doing these projects and want to follow along, I give you links to the kits I use in the description below, so you can have the exact same components I have. If you have any question, observation or feedback, please leave a comment below. Also, if you like this video, let me know by like, share and subscribe. Thank you and see you in the next episode.